So number one, what's our first go-to? A bunch of you skipped this step, maybe because I said to do algebra or L'Hopital. But what's our first attempt on any limit problem? Plug it in. Because sometimes it'll work, and if it works, you don't need to do anything else. So your first job is to plug in -5. We realize we get 0 over 0, and then that sort of triggers our brain of, okay, I've got to do something, either algebra or L'Hopitals. And it looked like it was kind of split on this one, because the algebra is not bad, if you can remember how to factor a cube. Let's see, same, opposite, always positive. And then the x plus 5s cancel, and we plug in again. So 1 over 25 plus 25 plus 25 is 1 over 6. It's frozen because I froze it. That's why it's frozen. There we go. Sorry about that. All right, gentlemen, we're working through number 1. Luca, we're looking at number 1.
Yeah, I did.
Okay, well, pay attention, not just zoned out on your phone back there. The other option would be L'Hopital's rule. That would also be pretty easy because the derivative of x plus 5 is 1. And then in the bottom, you'd have 3x squared, and that would lead you to 1 over 75. So that's a good one to illustrate algebra way or L'Hopital way. Either way is fine. Number 2, you plug in 0, we get, let's see, square root of 9 minus 3 over 0. And I'm not writing equal signs because it's not equal to 0 over 0. But that's my trigger that something is going on here. The algebra way is multiply the top and bottom by the conjugate. Most of you opted for the L'Hopital way, which I think is probably right. Just you have to be able to take a derivative of a square root. So that would be 1/2 x plus 9 to the negative 1/2. Chain rule, the derivative of the inside, that's just 1, so that's one of those spots where if you forget the chain rule, you're still okay. Derivative of 3 is 0. Derivative of x is 1. So we clean all that up, and you end up with 2 in the bottom and a square root of x plus 9 in the bottom. And then we try again with plugging in 0. So 1 over 2 square root of 9. That's a safe stop, but obviously multiple choice test, we need to get it to 1/6. So those two are good connections with what we did yesterday, L'Hopitals, and what we did way, way, way back. The first thing we did was limits. Number 3, everybody that I saw anyway factored it right and knew what was happening here and sort of what this problem's about. Factor it, and you cross out the x minus 3s. And so what does that mean? If you can take out a factor top and bottom, what does that mean about that graph? There's a hole there. So there's a hole at x equals 3. That's probably the first thing your mind thinks, and then you look at your answer choices, and none of them say hole at x equals 3. Well, none of them say it like directly, but which one of those means the same thing as hole? Removable discontinuity. That's the same thing as a hole. So that one tested a couple things, a little bit of factoring, but mainly that you know that a hole is an easier word for removable discontinuity. All right, 4 and 5 are a little weird, so let me work them sort of together with you. If I plug in 0, or something close to 0, sine over something really, really, really small. What's 1 divided by something really, really, really small? Something headed toward infinity. So we're trying to take the sine of infinity. If you think about the graph of sine, and it does that forever and ever and ever and ever and ever. So as we head out to infinity, the sine of infinity, what's this limit? Which one of these answer choices do you think is right? The limit means what are we getting closer to? Well, x is going to infinity, but the sign of infinity is between -1 and 1, but it never goes to anything, so it's non-existent. It doesn't converge, it doesn't head toward anything specific. Number 5, let f of x be this piecewise thing. Which of the following is true? And everything's happening at 1. Limit at 1, f of 1, f is continuous at 1. So we got to figure out what's happening at 1. Here we go again with a factor and cancel. So we know there's a hole at x equals 1. But how do I figure out what the y-coordinate of that hole is? So I get back in. So there's a hole at 1, 2. So this graph is x plus 1, but there's a hole at 1, 2. So I don't know if I want to graph this super accurate, but something like that is all of this. So it's the line x plus 1, but there's a hole at 1, 2. The second statement tells me that if x is 1, y is 4, so that's up there somewhere. Okay, so there's a decent picture of what's going on. So now with that picture, let's see if we can answer these. Does the limit exist as x gets closer and closer to 1? Does the limit exist? Do you remember the rule here? Are we okay that there's a hole there, basically, is the question for limits. Okay, I've got like 3 hesitant yeses and 23 no ideas. Well, the 3 hesitant yeses are correct. The limit does exist. The limit equals whatever value that was, 2. So that's true. So that's a good reminder that if there's a hole there, you can still have a limit there, because limit doesn't mean what happens at 1. Limit means what happens really, really, really close to 1. Well, really, really, really close to 1, we're getting really, really close to 2. So it's okay that there's a hole there. That limit exists. Let's see, we're looking for who's true. So number 1 is true. Statement 2, f of 1 exists. That's an easier question, I think. Does f of 1 exist? Yeah. What is f of 1? What's the function at 1? Yeah, 4. So f of 1 is 4. So that's true. Right, I think 3 is probably the easiest. Is f continuous at x equals 1? No, there's a hole there. So no, that's false. So 1 and 2 are true. Let's take a brief minute to remind ourselves the definition of continuity. It's a 3-step definition. Rare that they call on definitions, but continuity is one that they can sometimes say, use the 3-step definition of continuity to discuss the continuity of wherever. And that is, the limit exists, function exists, and the limit equals the function at whatever value we're talking about. So this number 5 did not really, it uses this, but that's kind of going on in the background. It's sort of referring to that. The limit exists, yep. The function exists, also yes, but they don't equal each other, so that thing is not continuous at x equals 1. Okay, 6 and 7 are pretty similar to 4 and 5, so why don't you try 6 and 7, and then I'll come back up here and we'll look at them in a moment. So what did you guys get for 6? What? And how does 6 different than 5? It fills in the hole. It's like the same setup. The first problem, there's a hole, but the second one, like fills the hole. So there's not, like taken together, there's not a hole. Branch A has a hole, branch B fills the hole, so there is no hole. So function exists, limit exists, it's continuous, it's all true. 7's pretty similar to 4. Like, what is the sign doing as we go toward infinity? Like, so B is like the explanation of the answer, but that's not really the answer. You don't say a limit is equal to, and then give an explanation. Either the limit has an answer, or it doesn't exist, and so the answer is D. That's pretty cool that they put that on an AP test, because B is like, yes, kind of, but that's not the official answer. So that was kind of tricky. All right, 8 through 12 are limit questions or other questions based on that picture. And I remember this test where we gave you a picture and asked you like 20 different limit questions. Most of the time you're pretty good at this. So take a few minutes to do 8 through 12, and then you're almost done. I'm going to pull some popsicle sticks while you're working.